Thanks, Marian. Thanks, CryptoCorn. As Marian mentioned, I'm Blase from the University of Chicago, and on behalf of my colleagues at Carnegie Mellon, I'll indeed be telling you about our password meter. As we all know, sometimes people make passwords that are easy for attackers to predict. One of the main mechanisms deployed in the web for helping people make better passwords is password meters. And they come in all shapes and sizes, and you find them all over the place. Unfortunately, the password meters that are widely deployed, many of them suffer from two major problems. The first is that they score passwords inaccurately. So for instance, on Twitter, if you type in the password, password1! Twitter will tell you that this is an awesome password. Unfortunately, it's not an awesome password. It's something attackers see all the time, and therefore it's something they're very likely to guess. And the disconnect here is because Twitter is basically just counting characters, giving you lots of extra credit for digits, symbols, and uppercase letters, regardless of what they are. Problem number two is that meters generally provide very unhelpful feedback. So if Twitter's meter decides your password is weak, it just tells you, please enter a stronger password. It doesn't tell you what you're doing wrong. It doesn't tell you how you can do better. So to address these problems, we designed and tested a meter that first provides principled strength estimates, and second, provides data-driven feedback to users. On this first point, principled strength estimates are hard to do because, for many reasons, you want to have a password meter that runs entirely on the client side. Right? So essentially what you're trying to do is fit an adversarial password guessing attack all the way down into a browser. And the way we do this is using artificial neural networks, in particular using an algorithm our group presented at Usenic Security back in August. And while we found that these artificial neural networks can provide password strength estimates that are fast, in real time, accurate, and also compact, we only just need to send a few megabytes of data to the client, unfortunately they don't provide very much intelligibility about why they're coming to the conclusions they are. And so that's not going to help us with the second point. How do we provide data-driven feedback to users? So to do so, we looked at different semantics and structures of passwords. So let's say if we're sitting in this room, one of you decides to make a password, and you're looking for inspiration. You might just look up on stage and say, well, I'll make unicorns my password. Right? And so we can look at the semantics and structures of this password, and there's a couple things we can tell you. We can look for this common characteristic of having dictionary words and say, well, unicorns is in the dictionary. And we could also look and say, like, oh, well, it looks like you changed the O into a 0. It turns out a lot of people do that, so hackers know to do this too. Right? We can look for that and tell people about that. We could also look and see how they're using capitalization in this password. And say like, oh, well, they're capitalizing the first character. Maybe a lot of people do that. Maybe we should be encouraging something different. Right? And so similar to these characteristics, we looked at 21 different characteristics of passwords that are common in data breaches. And basically from that, we basically, for each of these characteristics said, does this password have this characteristic? And if so, we generated text feedback like the ones you see above. Right? And to determine how to prioritize this feedback and not overwhelm the user with potentially 21 different types of feedback, we determined how to weight these different characteristics with a regression model. Okay? So that's how we scored passwords. The next step was how do we design the meter itself to provide this feedback to users? Okay? So we'll start with the main screen of the meter. Right. So as the user starts typing in the password, until they've met the password composition requirements, we're letting them know what the password composition requirements are and what they still have left. And we're also emphasizing to avoid password reuse, because that's one of the main security threats in the password space. And we also provide abstract advice about how to make strong passwords if a user is stuck. Right. So once the user's password has met the requirements, we start giving this data-driven detailed feedback. Right? The first place we're giving feedback is similar to other meters. We're displaying the score visually through a bar metaphor. Right? Different from other meters, however, we're also providing this text feedback about their particular password. Right? Because we wouldn't want to surprise a user, if their password's all asterisks, we wouldn't want to have their password blasted on screen in this text feedback. When their password is hidden, we provide more generic, non-sensitive feedback. However, when they click Show My Password on screen, we give even more detail. So rather than just saying, don't use a dictionary word, if they're using a dictionary word, we'll tell them, well, the dictionary word you're using is unicorn. Okay. Because we wanted to provide users the ability to learn why these different characteristics that we were noting in their password were bad, we provide these Y buttons. And if they click these Y buttons, we bring them to a modal window where we give more detailed explanations about why the things that we noticed are not good for password security and why the things we're recommending are better. So for instance, we might say, you're using digits at the end of your password. Turns out 38% of other people also do the same thing, and that's bad for security. Okay. So walked you through the meter's design. The next step was to test the meter to understand what impact all these different design decisions have on the security and usability of passwords people create. And to evaluate this, we conducted a two-part online study. In the first part of the study, participants created a password, role-playing that it was for their primary email account. Then they answered a survey about how they created a password, as well as how different aspects of the meter's design did or didn't impact the password that they were creating. After this step, we had participants try to recall their password. Then we let 48 hours go by, at which point we sent them an automated email so that they could return for the second part of a study in which we could test the memorability of the password. So essentially, they came back after at least 48 hours, tried again to recall their password, and then answered a survey about how they recalled their password. For instance, did they write it down? We had 4,509 Mechanical Turk participants run through our study, and it was a between subjects experiment. So each participant saw one variant of a meter. And we designed these variants in a full factorial design along 3 design dimensions. And the first of these dimensions was the password composition policy. We tested 2 different password composition policies. The first is pretty similar to what you often see across the web, requiring just 8 or more characters in the password. And this we call our 1 class 8 policy. And the second policy was more complex, required 12 or more characters from 3 or more classes. We call this our 3 class 12 policy. The second dimension we tested was the stringency of scoring. And what I mean by stringency is we estimated how many guesses this password would likely withstand. Then the question was, how do we map this to how much of the bar is full? So we tested 3 different levels of this, what we called our low, medium, and high levels. And so what we did is, for 1/3 of the bar to be full, we wanted it to be approximately, again, using rough numbers, such that this password would be likely to withstand an online attack where there's rate limiting. And so we tried 3 variants of this, 10 to the 4, 10 to the 6, and 10 to the 8 guesses in our 3 stringency conditions. For 2/3 of the bar full, we wanted it to be likely that the password would withstand an offline guessing attack, that is, where there's no rate limiting. And again, in very, very rough numbers, you have to think about how the different hash function, or the hash function that you're using, the attacker's capabilities. So this is just a rough estimate. But we tried 3 particular mappings: 10 to the 8 guesses, 10 to the 12 guesses, and 10 to the 16 guesses in our 3 different stringency levels, respectively. Our third dimension was how much feedback we were giving participants. So the lowest amount of feedback was giving no feedback whatsoever, other than whether the participant's password met the password composition requirements. The next step beyond this was similar to what current password meters do. We basically just give them the score in a bar, but we don't provide any of this text feedback. The next step beyond that is what we called our public non-sensitive feedback. So that is, whether or not a participant is showing their password on screen, we showed the same feedback we would in the text feedback that they would if they were not showing their password on screen. Right? So the next step beyond this is our standard feedback. And the difference here is when they click to show their password, we give these more detailed explanations. So for instance, rather than just saying dictionary words, we say it's unicorn, that's a dictionary word. Right? In addition to this detailed text feedback, we suggested an improvement to their password. That is, we wanted to basically give them some concrete advice, spur their imagination, and so we said we took their password and we modified it for them. Right? So for instance, we moved things around, we substituted characters, we added deleted characters, right? And this was our suggested improvement. Right? And all of this is all optional for the user to take into account. Right? To understand, in our standard meter, what impact different features had, we also tried a variant of the standard meter where there was no suggested improvement, as well as one where there was just no bar, that there was still all the text feedback. Right. to measure password security, we simulated an adversarial password guessing attack relying on work that we've built up over the last few years. And so this graph is going to show the guessability of passwords under different meter variants. And on the x-axis, we have the number of guesses made by an attacker on a logarithmic scale. And on the y-axis, we have the percentage of passwords guessed by that number of guesses. And so what this means is that lower is better. Lower means the passwords are harder to guess in that meter variant. So this first curve I have on screen is our 1 class 8 condition with no feedback. So that is, we're just telling people whether or not they've met the password composition policy. Right? And so now I'm going to bring in different levels of feedback. Right? And in our paper, we have full results about all of the other suite of security tests and analyses we did. Right? So what, first thing I'm going to bring in is going to be what happens if we just have the bar giving feedback without the text feedback. Right? And what we found is that the bar does buy us extra security. As we're giving more feedback, participants made more secure passwords. Right? So this is about what, this is the most analogous thing we had to the meters that are widely deployed, except we're scoring in a more principled way than these widely deployed meters. Right? So this is kind of the state of the art. So then the next question is, well, what impact did all of this detailed text feedback have? And the answer is, it had a lot of impact. Right? So that's the standard meter with the detailed text feedback is this purple bar. And so what we saw is that as we increased the amount and detail of this accurate feedback, participants made more secure passwords for our 1 class 8 condition. And that's the password policy that you see most often on the web. In contrast, for our 3 class 12 policy, we didn't observe the amount of feedback to have a significant impact on security. It was all very tightly clustered together, which we hypothesized might be because of a ceiling effect. I'd like to also quickly walk you through a couple of our key usability results. And interestingly enough, I'd say our key usability result is actually a non-result. It's that feedback did not significantly impact password memorability. And the reason why this is important is we just saw in the previous slide that as we increased the amount of feedback, participants made much more secure passwords. This is telling us that these much more secure passwords weren't more likely to forget them. Right? So essentially, we're getting this security win without harming the usability, without harming the memorability. Right? When we look at participant sentiment, however, feedback did have a negative impact on usability. As we added more feedback, participants were more likely to say that password creation was difficult or annoying. Right? In the paper, we take the reader through all the different aspects of the meter, and what we found is that all of the different features of the meter had value for at least some participants. So overall, we found that increasing the amount of this detailed, accurate, data-driven feedback led participants to make more secure passwords. Right? And because where we were getting the most security out of this was this data-driven feedback, and that's not something that meters widely used on the web have today, we've open-sourced our code. So it's available on GitHub, and this is also linked from our paper. Right? And based on our results, we recommend that it be deployed now for policies like this 1 class 8 typical policy on the web. We also are inviting you to join us in helping us improve the meter. Right? There's lots of work we want to do, lots of features we want to add, and it would be great to have this become very much a community project. Right? And if you're interested in not just downloading the code, but you're instead interested on just testing out the meter, we have a live demo there if you want to play with it. Right? And so yeah, please catch me in, or any of us on the team, in the hallway if you're interested in possibly deploying the meter, or if you're curious, like since when does the University of Chicago do HCI? Right? So, and so at this point, I'd be happy to take a number of questions.
Ben Zhao from UCSB. Blase, really nice work, especially really like the experimental design. Actually a couple questions, hopefully both quick. The first one, so did you guys consider some sort of generalizable entropy function as a way to replace the sort of the guessability metric locally?
Right, yeah, so I'd be happy to talk more offline about the particular guessability metric we used. The high level bit here is we basically simulate a bunch of the major conceptual approaches to guessing. These are tools like Hashcat and John the Ripper that are widely used by attackers, different probabilistic models like probabilistic context-free grammars Markov models, and we actually have previous work where we compared this. We hired a human expert in password forensics and compared our models to theirs. We found that this is a pretty good proxy for that. I'd be happy to talk more offline, and also to advertise our group's password guessability service, where you too, for free, can get these same kinds of measurements for your own research.
So that's a quality answer when you can turn the answer into an ad for yourself. That's well done. And then the second question, very quickly, did you guys try to test this out with some of the password manager automatic password generators? So like 1Password, they've got various knobs, and you can give it, tunable sort of passwords for memorability and those kind of things. Do they pass your test, and how well do they do?
Yeah, that's not something in particular we've tested yet, but it's on our long to-do list, and we've been in touch with folks from 1Password and some other places about this. But yeah, great thought.
Hi, Daniel Fisher, Microsoft Research. I really enjoyed this work. I've got a quick question. Early in, you talked about the idea of using a neural network analysis for the quality of the passwords, and then you switched over to this heuristic discussion. I'm trying to figure out whether the neural network stayed around or whether you switched over.
Right. So we use both. They
Okay.
both stuck around, and the reason for this is that basically that we're using the neural networks for this principled estimate of how attackers would guess passwords. But we need these heuristics along to say what are the characteristics of passwords.
In that case, are there situations where the neural network thinks it's just a fine password, but none of the heuristics apply, or converse, or vice versa?
Yeah, so it's what we found is that there is, to a large degree, agreement between the two. And conservatively, what we do is we with our regression model, with the heuristics, we also create a score. And so if the neural network, in this rare case, that neural network says this is a great password, and by these heuristics, we say this is not a good password, we will tell the user it's not a good password.
Or I'm actually worried about the vice versa, where the neural network says this is a terrible password, but all the heuristics seem to pass, and it's difficult to explain to the user.
Right, yeah, so that's, it's absolutely something that can come up. We didn't see it come up yet because some of the characteristics look like things like common substrings in passwords and like these and the structure of the password and the kind of low-level details. And so it's, even if you're not using like a dictionary word or capitalizing or using digits in an obvious way, we often would have feedback for you. We don't always, and so yeah, there are corner cases where we don't completely know what to say, but these are pretty rare.
Thank you.
Mm-hmm.
Is there any situation where you imagine that having more feedback in a certain context beyond email maybe is actually hurtful?
Right, yeah, well, so whether more, so yeah, there's a couple things I'd like to respond to on that point about whether more feedback can be hurtful. So I mean, one thing that could happen is if you're giving too much feedback, you could just completely overwhelm the user and then they just ignore everything. And so that's why in one of our early in our design process, we said, what are the key things we need to tell people? Because sure, we could come up with like a 10-page PDF of here are the results of your password along all these different features, and that people would just ignore that. So we designed it such that we wouldn't have that. There's also this question of basically as whether we didn't test multi-password interference. So like let's say if every site were to deploy this meter, it remains an open question what effect that would have if people would become habituated to it and ignore it, or if that would improve the state of passwords overall as people suddenly know what are these things that they're chronically doing wrong on all these different passwords. And so whether more feedback in the sense of more wide deployment of a meter like this is helpful or harmful is an open question.
Your best paper work. Congratulations.
Thanks.